In computer animation, sound usually comes last. Synchronized sounds are typically added to animations after the fact using canned, event-driven sound effects or by hand during audio post-production. Unfortunately, achieving perfect synchronization can be difficult, as recorded sounds never quite match physics-based animations. While digital sound synthesis can generate perfectly synchronized sounds, achieving the realism and richness of natural sound recordings is an ongoing challenge. In this work, we explore how to synthesize rigid body animations synchronized with input contact sounds. Given an input contact sound, such as from this real carton, our method, Inverse-Foley Animation, automatically optimizes a rigid body motion so that contact events are synchronized with the input sound events. We first build a physics-based model of the rigid body we seek to animate. Next, we pre-compute a database of randomly sampled rigid body motions hitting the ground, where each rigid body simulation is interpreted as a sequence of contact events. By finding similar contact events, we build a contact event graph which can be traversed to synthesize rigid body motions of varying plausibility. Given an input sound's contact time information, we search the contact graph to find a sequence of motions which have similar contact events at similar times. Given an input sound, the user identifies representative contact event times, which are either short-lived discrete events, such as a bounce, or longer, more complex continuous events, such as sliding, chattering, and spoling. Our system attempts to synthesize contact events with similar amplitudes and temporal variation. For example, this mug's final rolling contact behavior has a loud impact at the end, which our system synchronizes with. The user can also specify constraints on contact orientations, since some objects, such as this Lego, sound very different depending on which side they land. We have tested Inverse-Foley Animation on 27 objects and several hundred input contact sound recordings. We now show some synchronized rigid body animations that were generated automatically by Inverse-Foley Animation. The user can also specify approximate constraints on contact event positions. For instance, by leveraging sound to estimate contact event positions from video, Inverse-Foley Animation can be used for approximate audio-visual motion capture to estimate plausible non-smooth motions of fast-moving bouncing objects. Inverse-Foley Animation can also synthesize whimsical motions synchronized with non-physical input sounds, such as music, for use in content creation applications. For this funky drummer beat, blue dice are synchronized with hi-hat hits, and the red dice are synchronized with the bass and snare. Please see our additional videos for more results.